Hi everyone! In this video we will calculate the sample size required to estimate a population proportion. A physician at a community health center is interested in determining the effectiveness of a new diabetes management program. They have historical data suggesting that the success rate of the previous program was 60%. The physician wants to estimate the current success rate with a 95% confidence level and wishes the estimate to be within 4 percentage points of the true population proportion. Use a graphing calculator to determine the minimum sample size required to the program's success rate. To find the minimum sample size, we need to use our equation n, number of sample size, equals z of alpha halves, quantity squared, times p prime, the estimated proportion of successes, times q prime, the estimated proportion of failures, divided by the margin of error squared. We were already given the margin of error from the information in the question to be 4 percentage points. Changing this to a decimal is 0.04. The estimated proportion of successes and the estimated proportion of failures was not given to us for p prime and q prime. So we're going to estimate those to give us the largest number when they're multiplied together. That is a 50-50 split, so it makes it 0.5 to 0.5. The most tricky item to find is the z-score for the alpha halves. Let's talk about the 95% confidence level. The 95% confidence level for a normal distribution is 95% of the data in the middle. Because it's a confidence interval or a confidence level, we have the middle portion, 0.95. If we want to find the alpha, this is the outside portion, and because it all adds up to be 100%, those two outside portions together will give us the remainder. 100% minus 95% leaves us with 5%. And that's for both sides, so if we want just one of those, we'll divide by 2 to give us 0.025 for each side. If we want to find the z-score for all of the area to the left of this to include it all, then we will find inverse norm for the area to the left, which is 0.95 plus 0.025, giving us 0.975. So let's go ahead and open our calculator. To find inverse norm, we press second, vars for the distribution, and we go down to the third one, which is inverse norm. We can arrow down or we can press 3 and then press enter. The area to the left we've already found is 0.975. And because we're standardizing this, we'll leave the mean as 0 and the standard deviation as 1. And this will give us our z-score for all of the area to the left of 0.975. Pasting this into the home screen and then pressing enter will run. And this gives us our z-score, which we can write down as 1.95996. So we could write this into our equation. So we have n equals 1.95. Let's actually round that to the nearest 4 decimal places, which will round this to 600 squared times 0.5 times 0.5 over the margin of error of 0.04 squared. Now we can write this all out, or to help prevent any typos, I actually prefer to just square the answer. So we'll go to square, so the caret or the exponent button, squared, arrow out of the exponent, and multiply this by 0.5 for p, and then multiply it by 0.5 for q. And then we divide this by the margin of error, which is 0.04, and then we use the exponent or caret squared, and this gives us our number for the sample size. So n equals 600.227. Because we're dealing with people, we always round up no matter how small the decimal may be. So in this case, it's 601 for our sample size, and now we're all done.